So here's everything you ever wanted to know about parabolas and how to graph them. The formal definition of a parabola is the set of all points in a plane that are equal distances from both a fixed point, the focus, so that'll be one dot, and a fixed line, the directrix. D-I-I-R-E-C-T. All right, directrix. And that'll either be a horizontal dashed line or a vertical dashed line. If we zoom in on this picture right here, I can show you what we mean by that. Let's look at the vertical parabola first. We have the red parabola, and we can pick any point we want on it. They picked that point right there. What they're saying is that the distance from that point over to that point, the focus, and the distance from the point on the parabola down to the directrix, that blue line, that those lines are the exact same length. We could pick a point anywhere on the parabola. Let's say I picked a point over here. If I connected the focus to that dot and I measured that length, it would be the exact same length as if I connected the dot on the parabola straight down, so it's perpendicular to the directrix. Those would be equal. The same thing is true for the horizontal ones. So we have any point on the parabola, and they're saying that that distance to the focus and that distance perpendicular to the directrix, those are equal in length. The other thing I'll point out while we are zoomed in on this table is that the horizontal equations for parabolas start with x equals, and then the y is squared, and the vertical equations start off with y equals and the x is squared. So today when we're graphing these, you're going to need to identify a few things. The vertex, and then the focus and directrix, because we're going to make the parabola an equal distance away from both of those. So first, let's figure out the vertex and then which direction it's going to open. These are going to be centered at 0, 0, because see how there's nothing subtracted from the x or from the y? So we'll put our dot right in the middle. And now we need to think about which way it's going to open. Since x is first, this is going to be horizontal. And since it equals a negative number in front of the y squared, it's going to open to the left. So I'm going to make a quick sketch of a parabola that opens to the left, and I might change that later. That's kind of just a light sketch, so don't draw it in pen or anything, but that's the direction it's going to go. Now we know where the focus is going to go. It's going to go on somewhere on that blue line on the inside of the parabola. We have to figure out where though. The focus and the directrix are going to be equal distances from that vertex. So let's use the equation to figure out how far away it's going to go. And we do that by solving for p. That comes from right here in the equation. See that 4p right there? And then there it is underneath the other equation. If we take 4p and set it equal to that number right there, the 16 and the negative sign, and we solve it for p, we're going to get that p equals negative 4. That means that our focus is going to be 4 spaces from that vertex. 1, 2, 3, 4. So right there is F, the focus. So we not only need to graph that point, but we also need to name the coordinates. So we're going to say the coordinates of the focus are, and we just have to name where that ordered pair is. It's negative 4 on the x-axis, and it's 0 up on the y-axis. If you look at the table, you'll notice that the focus is p, comma 0, and our p is negative 4, and then comma 0. So it's the same thing as writing it by hand. Next, we will label the directrix. it's going to be 4 units the other way from the vertex. So 1, 2, 3, 4. It will be perpendicular to the line I drew down the middle. That line, by the way, is the axis of symmetry. It'll be symmetrical on both sides. So there's the directrix. I'm going to label it with a capital D. And now we need to write down what the equation for that directrix is. So I'm going to put the directrix. If we look up here, the directrix is the equation x equals negative p, the opposite of p. So negative 4 or positive 4, that's the equation. Another easy way to get the equation of the directrix is to look at what number your line goes through. See how it goes through 4 and it goes through the x-axis? So there's your equation, x equals 4. So now we have all the information we need. We just need to make sure that our parabola looks appropriate. So if we picked a point, I'm just going to pick a random point right there, and we measure the distance from there to the focus. See that red line? Is that the same length as that blue dot straight over to the directrix? No. What this tells us is that I drew my initial sketch of the parabola way too close to the focus. It's way too short here, and it's way too far away from the directrix. So I need to make my parabola wider. So that was just a sketch. I'm going to get rid of it. I know it opens that way. I know it opens to the left, but I'm going to make it so that it's much wider. And let's see if that looks better. So let's pick right there. Okay, I'm going to measure from there to the focus and there over to the directrix. That still looks kind of bad, so I'm going to make it even wider. If yours already looks good, you can keep yours. So I'm just going to keep fixing this. Alright, that's super wide. Let's see. Here's a random point. I'm going to connect it to the focus. I'm going to connect it to the directrix, and that looks a little better. So that's it. As long as your parabolas are reasonable, like a reasonable looking distance from each of those, then that'll be good. So let's try the next example. It's centered at 0, 0 because there's nothing subtracted from the x and y. All right, y is first. That means this is going to be a vertical parabola. And since that 1/8 is negative, it's going to open down. So I'm going to make a quick sketch of it opening down. Our axis of symmetry goes smack dab through the middle. It's the y-axis. I need to figure out where the focus is. In order to do that, I have to use that little 4p and set it equal to that. So 4p equals a negative 8. Divide both sides by 4, and we get p equals negative 2. That means that the focus is going to be 2 units down. It's always on the inside of the parabola. Label it with an F. And the directrix will be 2 units up, and it's going to be perpendicular to the axis of symmetry. So that red line I'm going to label with a D for directrix. Now I just need to jot down those points. So the focus is at the coordinate 0 over and 2 down. See how it's at negative 2? And the directrix is the equation. All right, it's too high and it's going through the y-axis. So the equation would be y equals 2. Let's confirm that my parabola is as wide as it should be. Let's pick a point right here. Okay, it's that far from the focus and it's pretty far from the directrix. So I'm going to make it wider. So let's try that one more time. That's a little wider. That's a little wider. Now let's pick a random spot on it, maybe right here. The distance from there to there, the distance from there to there. That looks pretty good. Now it's time to graph them when they are not centered at 0, 0, but HK. So if you recall, H and K come from whatever is right next to the X, that will be H, and whatever is right next to the Y, that will be K. And they go in order with the opposite sign. So since it's negative 2, or minus 2, it'll be positive 2, and since it was plus 5, it will be negative 5. So let's plot that point. 2 over and 5 down. This parabola starts with an x. It's x equals, so I know it's going to be horizontal, and since that number is negative, it's going to open to the left. If that number was positive, it opened to the right. So I'm going to make a quick sketch of a horizontal to the left parabola, and now I can see what it's going to look like. Now I can see where my axis of symmetry needs to be. It's going to go right down the middle of it. If we were to fold the parabola in half, that's where the axis of symmetry would be. So I'm going to put axis of symmetry, and I'm going to write the equation for that line. The line goes through negative 5 on the y-axis. So the equation will be y equals negative 5. All right, now we have to find p. So we're going to use the equation 4p equals that number. So negative 16. When we divide by 4, we're going to get p equals negative 4. That means we need to go 4 units away in each direction from the vertex. So I'm going to count 1, 2, 3, 4. That will be the focus. Label it with an F. We're going to go 4 the other direction. 1, 2, 3, 4. And that perpendicular line to the axis of symmetry will be the directrix. Now I just need to label what the ordered pair and what the equation of that line will be. So the focus is 2 units back. See how it's at negative 2 on the x-axis? And it's 5 units down. So there's our ordered pair. For the directrix, it is going through the number 6 on the x-axis. So our equation is x equals 6. The last thing we need to do is make sure our parabola is an appropriate width. So let's pick maybe that dot on the parabola. I'm going to connect it to the focus, connect it to the directrix, and it's not bad. It could be a little bit wider, but I'll just leave it like that. Last one. Let's find the vertex. It's going to be h, so the h is next to the x right here. K, which is next to the y right there. So here's h, here's k, which means the coordinate will be negative 2 and positive 1 for the vertex. So I'm going to go there. I'm going to go back 2 and up 1. All right. Let's figure out which direction this opens. It starts with a y, so that means it's going to be vertical. And this number is negative, so it's going to open down. So I know the parabola is going to look something like that. Now I can put on the axis of symmetry. It's going to go right through the middle so that it's symmetric on both sides. I'm going to label it axis of symmetry and write the equation. It goes through negative 2 on the x-axis. So the equation is x equals negative 2. Now I need to find p. 4p equals that number, negative 9. So we divide by 4, and we're going to get a decimal. We're going to get p equals negative 2.25. 0.25 is a quarter, like 1/4, so we can just kind of estimate where that should be. From the vertex, I'm going to go down 2 1/4 units. So I'm going to go down 1, 2, and then a tiny bit more right there. That red dot will be the focus. From the vertex, I'm going to go up 2, 1, 2 1/4, so just a hair more, and that will be the directrix. So I have labeled the focus with an F. I'll label the directrix with a D. And now we need those coordinates. The coordinates of the focus will be, let's see how far to the left we are, right here. We're back 2 units. And how far down are we? Well, we went down to the negative 1 and then just 0.25 after that. So negative 1.25. The directrix, how high up is that? It looks like it's 3 plus 0.25 more, and that's on the y-axis. So y equals 3.25.